Hey, what's up, folks? How's it going? And this is Abhijit here, and welcome to DevOps Challenger. So let's start with today's interview question, and let me share my screen. So today's interview question is: describe your experience with Amazon RDS in a production environment. So we can answer like this: like in production, I have used RDS and mainly SQL and PostgreSQL as the main database for our application, and yeah, we provision it using Terraform. So the database setup is fully automated and version control. Infrastructure as a code, Terraform. So database setup is fully automated and version control. And this RDS database sits inside the private VPC with proper security groups. It's in the private VPC because we don't need public to connect to database directly, right? So that's why it will be in the private VPC for security reasons. And for all production system, we will enable multi-agent for high availability. For testing environment, we don't need, but for high availability, we need to have a standby. So we need to maintain it in multiple data centers. So that's why multiple data centers is nothing but multiple availability zones. So we enable that multi-agent for high availability. And in our CI/CD pipeline, we don't database is part of it, but we don't create in every build. It is managed separately as an infrastructure as a code. So when developer adds a new feature, let's say there is a change in the database schema, a change, added a new column like phone number of the customer. Earlier, maybe we are capturing only email ID. Now we want to capture phone number also in the user table. So instead of doing that manually in RDS console or SQL command, we use migration tool like Flyway or Liquibase. So whenever we deploy a new release, so what is the advantage? Because it will, so again, it will be a script, and script will be the part of the pipeline, and it will be version control. It can be like same script can be used. If we do it from the RDS console, we don't know what a user has executed, may miss out something. So everything should be part of the code. If it is a part of the code, it's more reliable. It can be audited, and that's the beauty of infrastructure as a code, right? So whenever we deploy a new release, pipeline first runs the migration and staging, runs automated test cases, and only then we move to production. If it fails, then we won't be moving to production. And if it is a migration is risky, we do blue-green approach. So clone the database, apply changes, run the test, and if everything is fine, we just switch that DNS cut over to the new one. So route the traffic from old to new. For high availability, all production RDS database runs in multi-agent mode. This means AWS automatically maintains a standby database in another availability zone with synchronous replication. So AWS will be maintaining a standby database in another availability zone. If something happens to the primary, standby will be used. Traffic will be diverted to the standby. And if the main DB goes down, failover happens automatically, usually within 30 to 60 seconds. And we also have tested this using reboot with failover option during off-peak hours to make sure that application connects properly. We also added connection retry logic and pooling in the app so that users don't notice small failovers. And for disaster recovery, we set up cross-region read replicas. So if the complete region is down, so even availability zone also, multiple availability zone also won't help because the whole region is down. So there should be cross-region replica, read replica. For example, our database in Mumbai has a replica was in Virginia, US Eastern. And if primary region ever fails, we can promote the replica and point the application to the new endpoint. We also have automated a snapshot for every night to another region as a backup. So our DR is documented. It includes steps for promoting the replica, updating DNS, and running smoke tests to confirm recovery. We even do quarterly DR deals, disaster recovery deals to practice this and make sure our RTO, RPO targets are made. So in short, RDS as infrastructure, we manage RDS as the infrastructure as a code, integrate it safely with CI/CD pipeline for schema changes, ensure high availability with multi-agent failover testing, and maintain disaster recovery through cross-region replicas and snapshot backups. This setup gives us uptime, confidence that we can recover from failure quickly. Okay. So now let's go to the quiz section. You can pause the video and try to answer. Which RDS configuration provides automatic failover to a standby instance in availability zone? Which RDS configuration? Multi-agent deployment. Multi-agent provides synchronous replication to standby database in another availability zone. On failure, RDS automatically promotes standby. During an RDS failure, what happens to the database endpoint? Database endpoint, what will happen? So database endpoint IP will change, but DNS name will remain the same. And application is going to consider DNS name. So DNS name is not going to change. It's the same name. Whatever your XYZ backend database.com or whatever. And that DNS name, human readable name will remain same. IP address is going to change, but it doesn't affect the application because application is going to use the DNS name. RDS updates DNS records to point to the new primary. The DNS name stays constant, ensuring app transparency. Which RDS feature should be used to replicate data across AWS regions for disaster recovery? This is a cross-region replica. How do we typically integrate RDS schema migration into CI/CD pipeline? We include tools like Timeway or Liquidway. We don't do it from the RDS consoles because manually we don't want to do it. We want to do it through a script or Flyway Liquidway as a pipeline tool. Which infrastructure as a code tool is most commonly used in provisioning RDS in automated pipelines? So this is Terraform. What is the primary difference between multi-agent and read replicate RDS? Multi-agent is a synchronous one. We already discussed this in one of the videos earlier. Multi-agent is synchronous and read replica is asynchronous. There we discussed what is the difference between multi-agent and read replica. In a production grade CI/CD pipeline, how are risky schema changes typically handled? For risky schema changes, we do blue-green. Blue-green clone, migrate, cutover study. Blue-green migration isolates the schema changes to clone DB, validate before final cutover, ensure zero downtime, rollover safety. So that's it for today. Hope you like this video. Please like, share, and subscribe to my YouTube channel, and also follow DevOps Challenge Hub LinkedIn page. I post quiz contest daily. You can participate in that. Also join my WhatsApp communities where I post daily job updates, interview tips, career tips. You will get the link down below. And thank you for watching this video.